This is not a ship. Ships carry cargo. Ships move people. This is a machine, built to reach into the open ocean and lift an entire oil platform off the seabed in 15 seconds. There's a gap running through the middle of it, 59 meters across, wide enough for the Titanic to pass through. It weighs as much as 9 nuclear aircraft carriers at full load. The engines never stop because starting them from coal is too expensive to consider. 571 people lived there. The heaviest vehicle ever built, made for one specific job that no other machine on Earth can do. This is the pioneering spirit. The North Sea has been producing oil since the early 1970s. At its peak, it was dotted with hundreds of active platforms across British, Norwegian, Dutch and Danish waters. Most of those platforms were designed with a lifespan of 25 to 30 years. Many are now operating 20 years past that deadline. They sit out beyond the horizon, out of sight, but they powered Europe's economy for half a century, and the bill is coming due. Under the OSPAR Convention, international maritime law requires full removal once a platform stops producing. The entire structure has to come out, all the way down to the seabed, with nothing remaining above the waterline that could become a navigation hazard. The oil companies bear 100% of that cost, with no production revenue left to offset it. Before the pioneering spirit, the only approach was to cut a platform apart piece by piece, bring a fleet of crane ships to the site, divide the structure into dozens of sections, transport each one back to shore individually. Every day of offshore work in the North Sea costs hundreds of thousands of dollars. Weather windows close fast. Operations can shut down for weeks. And cutting into a corroded 50-year-old platform carries real structural risk. A miscalculation and the whole thing can topple. Using conventional methods, platform removal typically requires 18 to 24 months of offshore work. There are more than 600 offshore structures in the North Sea alone that need to come down before 2040. Globally, the figure is north of 7,500 installations, with the total bill running into the hundreds of billions. The industry had been staring at this problem for decades. A Switzerland-based offshore contractor named Allseas had been sitting on an answer since 1987. The concept started inside Allseas with technical director W.P. Koldenbach. In 1987, he put forward an idea the offshore industry had never seriously considered. Instead of cutting platforms apart at sea, build one vessel large enough to slide underneath an entire topside and lift it out whole. Allseas declared its intention publicly that same year. The first version of the concept involved connecting two supertankers side by side. The gap between them would be wide enough to straddle a platform. The problem was that supertanker hulls were never built for that kind of structural loading. The forces involved would have torn them apart. By 2004, the company scrapped that approach and started over. The new plan called for a purpose-built catamaran hull designed from the keel up around the requirements of the lift system. In 2007, 2 decades after the original idea, Allseas formally announced the project. They signed the main construction contract in June 2010 with South Korean shipbuilder Daewoo Shipbuilding and Marine Engineering. There is one chapter in this story that tends to get overlooked. The ship was originally named after Peter Schulte Hirmer, the father of Allseas founder Edward Hirmer. Peter Schulte was a respected figure in the Dutch offshore industry, but during pre-launch publicity, researchers found that he had served as an officer in the Waffen-SS during World War II. The backlash was immediate. Jewish groups and Dutch media organizations called for a name change. The ship departed South Korea in November 2014 and arrived in Rotterdam in January 2015 for final commissioning. In February 2015, weeks after arrival, Allseas renamed it the Pioneering Spirit. Construction ran from 2011 to 2014 at Daewoo's yard in Okpo, South Korea. Total cost, approximately $3 billion. The vessel entered service in August 2016. The Pioneering Spirit is a twin-hull catamaran, 2 parallel hulls joined by a massive cross-beam structure, with the gap between them being the entire point of the design. The hull measures 1,253 feet from stem to stern. Including the lift beams and pipe-lay stinger at the stern, the full vessel reaches 1,565 feet end to end. Width across both hulls, 407 feet, wider than a standard American city block. Cut into the bow is a slot 400 feet long and 194 feet wide. That opening is how the ship drives around a platform. When the slot frames the structure on both sides, the lift system engages. The weight distributes across both hulls through the crossbeam structure. The catamaran form prevents the topside load from creating a single-point tipping moment. The vessel has a deadweight capacity of approximately 415,000 tons. At maximum load, total displacement climbs to around 990,000 tons, making it the heaviest vehicle ever built. A Nimitz-class nuclear carrier displaces about 100,000 tons. The pioneering Spirit at full load is roughly 9 times that. The topside lift system uses 8 sets of horizontal lifting beams mounted on rails inside the slot. They travel forward along those rails to reach the anchor points on a platform. In industry terms, what the ship lifts is the topside, the entire above-water production structure. The legs and foundation come out separately using the ship's jacket lift system. But to any observer watching from a nearby vessel, the effect is exactly what it looks like: an oil platform being taken away in one piece. Maximum topside lift capacity, 60,000 tons in a single operation. The result of a 2022-2023 upgrade from the original 48,000-ton rating. A fully loaded Boeing 747 weighs around 440 tons. The system can handle the equivalent of well over 100 of them simultaneously. The ship carries a permanent crew on rotating 12-hour shifts. The engines stay on continuously because restarting from cold is too costly to make a planned shutdown practical. Positioning comes from 12 azimuth thrusters mounted under both hulls. Each one rotates a full 360 degrees. During a lift, their sole function is holding the ship in one exact location while the ocean works against it. Dynamic Positioning Class 3, the highest certification in naval engineering. But holding position is only half the problem. The ship is always in motion. The platform, anchored to the sea floor, stays fixed. In the North Sea, the tension between those two states, one floating and unstable, one rooted and immovable, is where catastrophic failures are born. In standard North Sea operations, wave heights of 3 to 5 meters are routine. Every one of them tests the same problem. Imagine the beams lock onto the platform's brackets. Ship and structure are now physically joined. A wave arrives, even a moderate 30-centimeter rise in the hull. The lift system hasn't fired yet. The ship is rising, and the platform stays fixed. 440,000 tons of steel just attempted to move through a structure that cannot yield. The forces generated could be catastrophic, far beyond a bent bracket or a snapped cable, with enough momentum to topple a 40-year-old corroded structure sideways onto the ship's own deck. The old crane ships used cables. Cables flex, but they also snap violently under sudden load reversals. There was no hydraulic system in existence at this scale, and the engineering window was brutally narrow. The lift had to happen faster than a single wave cycle. This is why the pioneering Spirit sat as a blueprint for 20 years. The physics problem had no solution until the technology caught up. The answer was built around one operating principle: decouple the ship's motion from the platform before the lift fires. The lifting beams function as enormous hydraulic shock absorbers. When the ship rises on a wave, the connection point at the platform can travel independently, absorbing the upward motion before it reaches the structure. As the wave passes through, the ship rises, the beam compresses, and the force never reaches the platform. Built into both hulls are banks of high-pressure nitrogen accumulators. As the ship descends with a wave trough, they store that energy. As the ship rises, they release it back through the beams in the opposite direction. The net result: the lifting arms stay approximately stationary relative to the platform, regardless of what the hull is doing below them. Laser sensors on the beams read the gap between ship and platform 10 times per second. Any drift beyond 4 inches triggers an automatic thruster correction before a human operator could even perceive it. The 12 thrusters, the nitrogen banks, and the sensor array all work in concert toward one moment: the valley between two waves, when relative motion between ship and platform reaches its minimum. That window lasts between 8 and 15 seconds. When it opens, the system fires automatically. The accumulators release, the beams take the load, and the structure that has been sitting on the sea floor for decades lifts free. The system operates under extreme hydraulic pressure throughout. If any seal fails at the moment of peak load, the fluid exits at enough velocity to cut structural steel. There is no recovery option. The lift has to succeed on the first attempt inside a window measured in seconds. In April 2017, everything in this story came down to one morning, 116 miles northeast of the Shetland Islands. The Brent field started producing oil in 1976. At its peak, in 1982, it was flowing at more than 500,000 barrels a day. Brent Delta was one of 4 concrete gravity-based platforms in the field. It stood in 460 feet of water on 3 massive concrete columns rising from the sea floor. Shell commissioned Allseas to remove the entire topside in a single lift, intact. Months before the Pioneering Spirit arrived, remotely operated vehicles were at the site. Their mission was to pre-cut those 3 concrete columns almost all the way through. Enough material remains to hold the structure stable, while leaving just enough margin for the lift to break it free cleanly. Every foot of the ship's approach was modelled. The slot-in manoeuvre was simulated thousands of times. Engineers mapped every failure mode and built a protocol for each one. On April 28, 2017, the Pioneering Spirit arrived at the Brent field. Threading the 400-foot bow slot around the platform's legs required less than 17 feet of clearance per side. The navigation team called out position measurements in near silence, while 12 thrusters made continuous micro-corrections. The beams travelled their rails, found the lift brackets, and locked into position. The sensors started reading the ocean. The nitrogen banks charged to full pressure. The system tracked the wave cycle and waited for the valley. It was a short wait. When the accumulators fired, all 8 sets of beams lifted simultaneously. The topside separated from its concrete columns, and for the first time in 41 years, Brent Delta was no longer connected to anything below the waterline. The lift took approximately 10 seconds. The Pioneering Spirit moved off immediately. The concrete legs were left standing in the water, empty, exactly as planned. The topside was sea-fastened on deck and transported 435 miles to a decommissioning yard in Teesside, northeast England. The total weight lifted in that single operation was approximately 26,500 tons, the equivalent of a fully occupied 15-story office building taken off its foundations in one piece. The previous world record for a single offshore lift was well below that figure. The Pioneering Spirit set the new mark, at roughly half its rated capacity at the time. The conventional alternative would have taken 18 to 24 months of offshore work. 5 years of planning, months of underwater preparation, and 10 seconds on the day. When the Pioneering Spirit is finished removing platforms, it converts to something almost unrecognizable. The bow slot reconfigures, and the ship enters pipeline mode. Inside the hull, robotic welding stations run 24 hours a day, 7 days a week, joining steel pipe sections in a continuous cycle. The finished pipeline exits through an articulated ramp at the stern, which guides it down to the seabed at controlled angles. The ship can work at pipe depths exceeding 6,500 feet. Between 2017 and 2018, the Pioneering Spirit deployed to the Black Sea for the Turk Stream pipeline project, 578 miles of gas pipeline running from Russia to Turkey. The pipeline carries Russian natural gas, a project that became significantly more controversial after 2022, but the Pioneering Spirit's role was purely construction. On August 26, 2018, it set a world pipe-laying record by laying 3.9 miles of pipe in a single 24-hour period. In July 2025, the ship completed its first major heavy lift operation outside European waters, the installation of a 25,000-ton drilling platform at Synovus Energy's West White Rose development, offshore Newfoundland and Labrador, Canada. The operation took under 2 hours and was the first heavy lift of its scale in North American offshore history. By 2024, the Pioneering Spirit had removed all 4 Brent field platforms, culminating with the Brent Charlie topside in July 2024, a 31,000-ton lift that broke its own 2017 world record. Since its first commercial deployment in August 2016, the Pioneering Spirit has worked in the North Sea, Black Sea, Baltic Sea, Mediterranean, and North Atlantic. After the Brent Delta lift, Allseas committed to building a successor. The project was named Amazing Grace. The proposed specs were larger across every dimension: a topside lift capacity of roughly 72,000 tons, wide enough to handle the largest concrete gravity platforms in the North Sea that the current vessel cannot reach. In July 2020, the project was suspended indefinitely. COVID-19 and a collapse in oil prices made the economics impossible. The basic engineering design was completed and archived, meaning construction could move forward relatively quickly if market conditions changed. No construction contracts were signed. As of 2026, Amazing Grace remains on hold. The Pioneering Spirit is still the only vessel of its class in service, with no operational competition in the global fleet. The offshore wind industry is scaling fast. Converter stations and substation structures for next-generation wind farms are reaching weights that exceed what standard installation vessels can handle. The Pioneering Spirit has been completing offshore wind installations since 2024, and Allseas holds a project pipeline stretching more than a decade forward for European offshore wind work. The ship built to clean up the oil age is now installing what comes after it. Among all working vessels, the Pioneering Spirit ranks well below the top in length, speed, and name recognition. What it has instead is a waiting list. And on the open ocean, 125 miles from shore, that is the only metric that matters. 30 years to build. Nothing like it has ever been built again. Do you think we ever will? Let us know in the comments. Subscribe for more MegaBuilds stories.